Picture a landscape in your mind right now. But don't picture a sprawling forest or, a bustling cyberpunk city. Strip all of that away.
Just completely empty it out.
Right. I want you to visualize a stark, infinite grid. Just a checkerboard stretching out endlessly in literally every direction.
Yeah.
Pure, unadulterated white and absolute pitch black. That is the entire world.
It is a very intense mental image.
Yeah. And right in the center of this endless, disorienting geometry sits a massive, imposing cube.
Oh, wow.
Driven directly into the top of this cube, just sunk deep into the black and white material, is a sword. And this sword is glowing. It is radiating this brutal, piercing, hyper-specific shade of crimson light.
It's just such an arresting visual. There is a hostility to it, but also, an incredible sense of focus. You look at that image and you immediately know the rules of the universe you're stepping into.
Exactly. And that feeling of stark geometry and brutal contrast is our entry point today. We are doing a deep dive into the architecture, the aesthetics, and the completely wild development process behind a 32-bit retro adventure engine.
Right, the one known as Sword Slasher.
Yeah, Sword Slasher. Though in the documentation we're looking at, it also goes by the subtitle Red Optimum Dark Link.
Which is quite a mouthful. But that subtitle alone kind of hints at the underlying complexity here. We are looking at a project that presents itself as a simple retro game on the surface, but it operates on incredibly sophisticated logic underneath.
Yeah, we aren't just looking at a finished piece of media today. We are unpacking a highly sophisticated, data-driven digital ecosystem. We actually have access to the engine source code, the developer's internal logs, the raw AI chat transcripts, and the visual blueprints.
The whole playbook.
The entire thing. We get to look at the exact gears turning inside this machine. And to understand how those gears turn, we have to explicitly lay out the thematic thread for you, the listener, because it dictates every single decision in this project.
It really does. Everything.
Everything in Sword Slasher revolves around the interplay of white, black, and one very specific hex color code. Hashtag DE2626.
That is the exact digital color value of that brutal glowing red sword.
Right. And that specific color palette isn't just window dressing. It's not a filter slapped on at the end of development.
Yeah.
It is the literal and metaphorical lifeblood running through the code, the UI, and the game's core identity.
It dictates what the game is, and frankly, more importantly, what the game is not allowed to be.
Yeah.
When you constrain the visual vocabulary of a project to just white, black, and that hashtag DE2626 red, you are forcing a very specific kind of focus onto the developer. Every design decision, every piece of underlying logic, every enemy behavior, it all has to conform to that brutalist aesthetic.
There's no room for soft pastels or gentle gradients.
Exactly. The mechanics have to be as sharp as the color.
So before we even look at a single line of code or talk about the physics engine, we need to understand how the creator established that vibe. Because you can't build a mechanical world without setting the atmosphere first.
You really can't.
The developer is Sword Slasher, a solo dev named Elton Bonin. He established this atmosphere through a fascinating collaboration with an AI to create the soundtrack and the initial album art.
And that conceptualization phase is often the most vulnerable part of solo development. The blank page is just terrifying.
Oh, absolutely.
But he didn't just ask an AI to generate some generic fantasy art to get started. He built the walls of the sandbox immediately.
Yeah, looking at the developer logs, the initial conversation with the Gemini AI model is wild.
Yeah.
He doesn't just request a picture. He sets incredibly rigid constraints.
Right. He lays down the law.
The prompt literally demands, and I'm quoting here, theme. White, black. Hashtag DE2626. Text, Sword Slasher. Checkerboard. Sword in the queue. End quote. He is demanding that the AI submit to this exact aesthetic vision.
And the iteration process log there is crucial. The first output is never the final product. He tells the AI, badass alternative, please, you can rotate colors around too.
Yeah, he's fine-tuning it.
He is fine-tuning the exact placement of that hashtag DE2626 red against the harsh black and white checkerboard. He's searching for the perfect visual anchor, because once that anchor is set, every other decision has a definitive reference point. The audio, the code, the map design.
Well, speaking of the audio, the soundtrack generation is where this process crosses from a standard tool-user relationship into something much stranger.
It really takes a turn here.
He hands over a massive, chaotic archive of raw MP3 files to the AI and essentially says, make an official soundtrack album out of this noise. And the AI's response is just incredible.
It doesn't just output a track list.
No, It adopts a persona based on the art they just created. The AI literally replies, "I am the sword in the cube," and your soundtrack is officially ready to deploy.
It takes on the identity of the central icon of the game. That level of digital anthropomorphism completely shifts the dynamic of the development process.
Right.
The AI is no longer a passive calculator. It is an active participant playing a role within the fiction of the universe they are building together.
So the AI tells him, "Here is the album art, forged exactly to your specs.
Yeah.
Pure black, white, and that brutal hashtag DE2626 red, complete with the checkerboard matrix."
Yeah.
And then it takes that chaotic folder of audio files and organizes them into a true sequence of 9 tracks, labeled SEQ01 through SEQ09.
And if you look closely at that generated sequence, there is a brilliant little artifact in there. The AI intentionally retains a glitchy dual O5 sequence.
Yeah, wait, explain that part.
So you have a track called O5 The Unmanned Floor, and then immediately following it, there's another track labeled O5 Stalking Prey.
2 track 5s.
Exactly. And the AI explicitly notes in the chat log that it retained this dual O5 sequence from the original mainframe logs.
It's like buying a pristine digital album and finding out the producer deliberately engineered the sound of a scratch on a vinyl record into the master track.
That's a perfect way to put it.
It adds this rough, imperfect texture to an otherwise sterile digital environment.
It reinforces the fiction. It makes the world feel like it existed before the player even arrived, complete with its own corrupted data and mainframe glitches.
Let's actually look at the tracks the AI curated, because
Yeah.
they perfectly map the sonic landscape of that checkerboard. Track 1 is System Boot Vanilla Engine, which the logs describe as an ominous, pulsing synth intro.
Right. It builds slowly.
Yeah, mimicking the feeling of a massive digital realm loading into memory. Then track 2 drops, the checkerboard realm,
And this one is described as a high BPM, erratic electronic track.
which perfectly matches the visual of a stark, repeating pattern of black and white squares.
Yeah.
I mean, if you stare at a high-contrast checkerboard long enough, it literally hurts your eyes. It feels erratic.
The music is mimicking that visual disorientation.
Exactly. Then we hit the title track, Red Optimum.
Heavy, distorted bass drops and grinding industrial beats.
That is pure hashtag DE2626 audio. If that color had a sound, it would just be grinding metal and distorted bass.
Absolutely.
Finally, the album ends with Sword in the Cube, a triumphant heavy metal crescendo that slowly fades into a stark, echoing heartbeat.
From a project management perspective, this is just a masterful way to begin a solo indie game.
Well, hold on, though. I want to push back on that a bit. If you are an indie dev with limited time and resources, doesn't it seem a bit unhinged to spend hours role-playing with your AI tools?
I mean, I see how it looks that way.
Right. Giving the AI a persona, having it speak to you as the sword in the cube, engineering artificial glitches into a track list. Isn't that just theatrical procrastination from actually writing the game's code?
It sounds highly theatrical, yes, but it is highly functional theater.
How so?
Think about it. If you are a solo developer staring at a blank screen, you are burdened by infinite possibility. Your game could look like anything. It could sound like anything.
Right, the paradox of choice.
Exactly. That freedom is paralyzing. By establishing this rigid, minimal aesthetic, the checkerboard, the specific red, the heavy industrial soundtrack, and by role-playing that out with the AI, he creates immediate, unbreakable thematic cohesion.
So it's about eliminating decision fatigue before the real work even begins.
Precisely that. 3 months later, when he is writing a complex rendering function for a particle effect, and he wonders what color the sparks should be, he doesn't have to spend 30 minutes agonizing over a color wheel.
The answer is already decided.
It's hashtag DE2626. When he needs a sound effect for a heavy sword attack, it needs to sound like the grinding bass of Red Optimum. The aesthetic constraints act as a permanent compass for the entire engineering process.
Okay, that makes a lot of sense. So we have the vibe, we have this stark, brutalist aesthetic. Let's open up the box and look at the engineering now. What is actually inside that checkerboard cube?
Let's get into the code.
We are transitioning from the external atmosphere to the internal skeleton of the engine itself. And this brings us to a piece of architecture called the MFDB.
The Medium Format Database, version 1.31. This is the absolute structural heart of Sword Slasher.
To give you some context, if you aren't familiar with game development, most modern indie games are built using massive visual editors like Unity or Unreal Engine, right?
Yeah, very visual drag-and-drop interfaces.
You drag a 3D model of a tree into a window, you attach a script to it, and you press play. Sword Slasher does not work like that at all. The entire game, every level, every event script, the player stats, the enemy behaviors, the items, the biomes, is driven purely by text data.
Pure
And it's structured in a bespoke format called JSON documents.
Let's break down what JSON is for a moment, just because it's so crucial to understanding this architecture.
Yeah, please do.
JSON stands for JavaScript Object Notation. It is essentially a highly organized text file that uses brackets and commas to store information like a nested filing cabinet. It's how most of the internet sends data back and forth.
So if you have a sword in standard JSON, it might say name, quote, iron sword, damage 10.
Exactly, but standard JSON is very loose. You can put almost anything anywhere, which is great for the web, but dangerous for a tightly controlled game engine.
So he didn't just use JSON, he created Beson, a bespoke version with incredibly strict, borderline obsessive rules.
Yeah, reading the documentation, it is full of what he calls library parity reports.
Those are fascinating.
He is mandating that the TypeScript Beson library, which is the code running the game in the web browser, must exactly mirror implementations in Python and Bash, which tells us a massive amount about his long-term vision for the project. TypeScript is for the web. Python is generally used for local offline compiling or running machine learning scripts. Bash is used for server administration.
Right.
By ensuring the core data logic works identically across all three, he's building an engine that is completely platform agnostic. The game isn't trapped in a browser. It exists as pure translatable logic.
And the strictness of this system is where things get really wild. There is a rigorous 3-level validation process for every single BJSON file before the engine will even attempt to load the game.
Let's walk through those layers because it shows the paranoia in the design.
Yeah.
Level 1 is the manifest level. Think of this as checking the table of contents of a massive encyclopedia.
Okay.
It validates the custom headers. It checks that the MFDB version matches the current engine build. It checks that the DB name is correct. And it ensures that there are unique, non-null mappings for every single entity name and file path in the entire game.
So it's basically asking, does all the paperwork look right before we even open a folder?
Exactly. And if the table of contents is perfectly clean, it moves to level 2, the entity level.
This is where it opens the individual file, right?
Right. It checks that it is formatted in valid BJSON version 104. It checks for a valid relative parent hierarchy, which allows objects to inherit properties from each other. It checks naming constraints. And crucially, it guarantees no root escaping.
Okay, we have to unpack root escaping because the parity report specifically highlights a TypeScript function called escapes root.
This is a huge deal in web security.
If you aren't familiar with cybersecurity, root escaping or directory traversal is a classic vulnerability. If a system expects a file path, like images/sword.psen, a malicious user might input .. //
Right, trying to sneak out of the sandbox.
The .. command tells the computer to go up one folder. If you do it enough times, you escape the games folder and end up in the root of the computer's hard drive. It's like someone in the lobby of an office building prying open the elevator doors and climbing down the shaft into the basement vault.
It's a massive security risk in web applications. What's fascinating here is that he is building this security checkpoint directly into a single-player game engine.
Yeah, why?
Well, the escapes root function physically counts the depth of the current directory, counts the number of .. attempts in a file path, and if the attempts exceed the depth, it hard crashes and throws an error.
It's a level of structural paranoia that I find fascinating. Why does a solo developer care about path traversal in their own closed ecosystem? Is he expecting players to hack the game?
It's not really about hackers, it's about structural integrity. If you are building a database that will eventually house thousands of interconnected files, weapons, monsters, dialogue trees, one accidental bad file path could corrupt the entire memory state.
Oh, I see.
He isn't just protecting against malicious users, he's protecting the engine from himself. He is demanding perfection from the data.
And he documents the failures meticulously. The parity report lists exact error codes. Version constraint is error 17, invalid custom key is error 18, null document is error 41.
And this is the beauty of the multi-language parity we talked about earlier. If the Python compiler script throws error 17 while building the game offline, he knows exactly what failed in the exact same way the TypeScript engine would have failed in the browser.
So if the file survives level 2, we hit level 3, which is database-wide validation.
This is where the engine checks the relationships between all those isolated files. It implements warning metrics for advisory record counts, and most importantly, it validates foreign keys.
Right, the connections between things. So if a chest in level 4 contains an item called rusty key, Level 3 scans the entire database to ensure a file defining the properties of a Rusty key actually exists in the manifest.
Exactly. And if it doesn't, the game simply won't load.
It prevents those classic video game bugs where you open a chest and receive a glitched item, or the game crashes because it tried to load an asset that someone forgot to include in the final build.
It forces you to fix the broken link before you even playtest.
But looking at all of this, the custom formats, the parity reports, the 3-level validation, I have to ask, is this actually a good idea?
It's a fair question.
I mean, building a bespoke database format from absolute scratch feels like reinventing the wheel just so you can paint it #DE2626red. Why not just drop in a standard proven technology like SQLite and save yourself months of engineering time?
It is always dangerous to reinvent the wheel. Software engineers are constantly warned against not invented here syndrome.
Exactly.
But if you are tasked with building a very specific type of vehicle, say a rover designed to drive on the surface of Mars, a standard rubber tire from a Honda Civic isn't going to work.
Okay, I like this analogy.
The environment is too hostile. You need to build a bespoke wheel out of aluminum and titanium mesh.
And you're saying Bigison is the Mars rover wheel for Sword Slasher?
I am. Standard JSON is just too loose. It doesn't enforce schema validation natively. You have to build massive external libraries just to check it.
And what about SQLite?
SQL is incredibly powerful, but it's a heavy dependency. It requires a SQL engine to run, it locks your data into a binary file format, and it's notoriously tricky to integrate seamlessly into web browsers without significant overhead.
Ah, so Bigison strikes a very specific balance for his needs.
Exactly. It provides the strict schema validation he craves. He knows instantly if a script used a string of text where an integer number should be. It has hierarchical parent-child relationships built natively into the format.
So you can have a generic base sword file and then a fire sword file that just says inherit base sword and adds a fire damage value.
Right. It keeps the data clean and avoids repetition. And it does all of this while remaining pure, human-readable text. The gains data from the execution logic, he gains immense flexibility. He can build visual editing tools in React to draw the maps. He can write an offline compiler script in Python, which the logs actually note as compile.py to crunch the data down.
Or he can run the whole game live in a web browser.
Exactly. And all of those vastly different systems are just reading the exact same highly validated text files. The database is the game. The engine is simply a viewer for that data.
It's an incredibly robust skeleton. But I mean, a skeleton is just bones. A database is just a spreadsheet until you actually build the dirt, the trees, and the dungeons for the player to explore.
You need the flesh and blood.
Right. So how did he actually translate those text files into a physical checkerboard landscape?
We find the answer to that in a document called agents.md. It outlines the map design guidelines, and it really reads like a manifesto for solo indie game design.
It starts by issuing a very stern warning against two massive pitfalls that destroy indie games: the master plan and the blockout.
Let's talk about the master plan first, because it's a classic trap. It's analysis paralysis.
Yeah, we've all been there.
It's trying to design every single blade of grass, every enemy encounter, and every puzzle on graph paper before writing a single line of code. You get bogged down in microscopic details that will inevitably need to change the second you actually play the game and realize, oh, the character's movement speed is slightly faster than I thought.
And suddenly your entire graph paper map is ruined.
Exactly.
And then the blockout is the exact opposite problem.
Yeah.
The booting up a 3D editor, building a bunch of random disconnected rooms just because they look cool, and then trying to retrofit a cohesive game narrative and logic into them later.
It makes the world feel incredibly artificial and disjointed. It feels like a theme park ride, not a living world.
So to avoid both of these extremes,
Yeah.
the documentation proposes what it calls the hybrid workflow.
And step one of this workflow is the macro dependency graph.
Walk me through that.
Before you draw a single pixel of a map, you map the game's logic. You flowchart the player's progression through items and abilities. So the player starts the game. They encounter a rock locking a cave. Therefore, they need bombs. Inside the cave is a lake. Therefore, they need flippers to cross it.
It is the classic Zelda formula, distilled down to pure, abstract logic. Need bombs, go to cave, get flippers.
Right. You don't know what the cave looks like yet, but you know its structural purpose and the pacing of the game.
And once you have that logical graph, you move to the open gray box phase.
This is building fast and ugly.
Yeah, you throw down gray squares just to test the physical scale of the world and make sure the walking distances feel right. But then, we arrive at the real magic of this engine's world design. the carving method.
This is a procedural and manual subtractive design workflow, and the word subtractive is the key to everything here.
Think about how you would normally build a video game forest. It's an additive process. You place one tree, then you place another tree next to it, then you place a rock. You are building the environment object by object.
The carving method is totally different. It's like actual physical sculpture.
Phase 4 of the workflow outlines it step by step. First, you run procedural generation, often called progen, but you don't use it to generate the level itself.
Right, you use it to generate a block of marble, essentially.
You use it to generate a dense, completely impassable base layer. You use noise algorithms to create an infinitely thick, solid block of digital stone or an impenetrable canopy of trees.
And then you take a virtual chainsaw and you start carving out the playable space from that solid block.
It's so visceral.
And the order of operations for carving that block is meticulously defined to ensure the resulting space feels good to play in. Step 1, carve the points of interest, the POIs.
Okay, what are those?
These are the major clearings, the boss arenas, the dungeon entrances, the peaceful camps. You hollow out the massive spaces first.
Got it. Step 2 is carve the arteries, the golden path. You take your chainsaw and you cut a clear, obvious path through the noise connecting those major POIs.
Yeah.
This ensures the player always has a primary route to follow to advance the game.
And then step 3 is where the psychology of game design enters the chat. You refine those arteries by carving choke points in arenas. The guidelines explicitly state widen arteries for combat arenas, narrow them for suspenseful corridors.
This directly ties into the psychological principles of map design listed earlier in the agents.md document. They emphasize deliberate pacing, balancing tension versus respite.
It's manipulative in the best way. If a player is walking through a wide, open clearing, they feel relatively safe. They can see enemies coming, respite.
Yeah.
But if they're forced to squeeze through a narrow, carved choke point where they can't see around the corner, their tension spikes. By manually widening and narrowing the carved path, the developer is actively manipulating the player's heart rate.
Step 4 is place locks. You add physical obstacles like a massive chasm or deep water blocking the golden path, and you place these locks based precisely on that macro dependency graph we talked about earlier.
So you put the water lock right before the area where the flippers are required?
Exactly. Step 5 is carve loops. These are the shortcuts that connect the end of an agonizingly difficult area back to the beginning, usually using one-way ledges or doors that can only be unlocked from the inside.
The document refers to this as gated exploration. You tease the player. You let them see an inaccessible treasure chest on a high ledge in the very first hour of the game.
Oh, that drives me crazy in games.
It drives everyone crazy. But then, 10 hours later, they carve a loop through a new dungeon and drop down onto that exact ledge. It's one of the most rewarding feelings in gaming.
Finally, step 6 is carve veins. Secrets. You take your chainsaw and you cut tiny, twisting dead ends off the main path. You carve small visual gaps in the dense tree line to tease hidden areas and reward players who push against the boundaries of the map.
It's an incredibly methodical, almost surgical way to design a game world.
But I keep coming back to the effort involved. Why go through all this trouble? Why generate noise and cut it away instead of just drawing the path you want in the first place?
Because carving a path through mathematical noise inherently creates a world that feels ancient and organic.
Okay, explain that.
If a human draws a winding dirt road on a blank canvas, it often looks artificial. The curves are too perfect. But if you generate a chaotic, jagged wall of procedural noise and you carve a path through it, the boundary of your path is defined by the jagged, unpredictable mathematical edge of the noise you didn't cut away.
Oh, wow.
It makes the world feel like it wasn't constructed yesterday for a video game, but rather like it was worn down over centuries by erosion and footsteps.
That makes total sense. So we have the stark visual theme, we have the incredibly rigid Bayesian database architecture, we have the subtractive carving method for generating the physical space.
The bones, the blood, the map.
Now that world needs to be populated. It needs art. It needs characters. And this brings us to one of the most fascinating aspects of Sword Slasher's development, the ghost in the machine.
Yes. We're looking at how the Gemini AI is integrated into this project. It is not just a brainstorming partner acting as the sword in the cube persona anymore. It is deeply technically wired into the game's live development tooling.
Let's look at the server.ease file. This is the back-end code running the local server while he is building the game. It features an AI sprite engine. Now, anyone who has messed around with AI APIs knows they are notoriously flaky.
Oh, they constantly time out. They refuse requests.
And if you are an indie dev in a flow state, waiting 30 seconds for an API to fail ruins your entire momentum.
To combat this, he engineered a 7-tier hardware fallback chain of Gemini models.
A 7-tier chain. It's configured for extreme high availability. It requests a sprite from the primary, most powerful model, Gemini 3.5 Flash. If that request times out or fails, the server automatically catches the error and instantly routes the request to Gemini 3.1 Pro Preview.
And if that fails, it falls back to Gemini 3 Flash Preview, cascading down a chain of 7 different models until one of them successfully returns the asset. It refuses to let the workflow be interrupted.
And it is generating these assets on the fly in 2 very specific formats.
Right. It can output 32 by 32 pixel art grids.
And in this mode, the AI doesn't return an image file.
No, it outputs a literal JSON array containing exact hex codes for all 1024 pixels, including our favorite hashtag DE21626 or the word transparent.
Or, for higher fidelity assets, it can output perfect, clean SVG vector paths. If you aren't familiar with graphic design, pixel art is a grid of colored squares. If you zoom in, it gets blocky. Vector art, like an SVG, is made of mathematical equations defining lines, curves, and shapes.
You can zoom in infinitely, and the edges remain perfectly smooth and sharp.
But the absolute most technically impressive part of this sprite engine is a prompt engineering rule labeled Critical Visual Lineage Continuity.
This rule is attempting to solve a massive fundamental problem with AI art generation. If you asked an AI to generate a cool knight facing forward, it will give you a great image. But if you take that image and say, okay, now draw that exact same knight from behind, the AI completely hallucinates. It gives the knight a different cape, different hair color, different armor plating.
It's so frustrating. The AI has no object permanence. It has no memory of the 3D space that the character occupies. It just generates a brand new picture of a back.
Exactly. To solve this amnesia, the server.easex code forces lineage continuity.
How does it do that?
If he clicks a button to generate a back-facing view of an enemy, the system code physically intercepts the request. It grabs the exact hex color palette and the structural layout data of the front-facing view and forces the AI to ingest it as part of its core system instructions.
The hidden prompt injected into the AI literally says, and again I'm quoting, you must refer to the following front-facing view data as the layout and color palette source. Translate this palette and visual layout faithfully into its rear perspective counterpart, hiding facial details, displaying hair/back of garments.
It is forcing aesthetic consistency through sheer computational willpower. Just like he constrained the album art to 3 colors, he is constraining the AI spriter to the established, pre-existing palette of the character.
But the AI integration goes even further than generating art. There is an executive system advisor built directly into the game's developer user interface.
Right, he can chat with this AI while he is actively playtesting the game.
And this advisor is granted read access to the live, active snapshot of the virtual MFDB. It can read the entire game state.
It knows the player's health, it knows what items exist, it knows the map layout.
However, it is operating under very strict, hard-coded mandates. Mandate number 1, under no circumstances can the AI edit the game files directly. Mandate number 2, if the AI suggests a database change to fix a bug or balance an enemy, it must output strict BSON in a markdown code block tagged with a specific / file name header.
For example, if it wants to make an enemy weaker, it outputs a block starting with / file name :data / enemies / goblin.bjson.
And this specific formatting allows the human developer to see the suggested code, review it, and click a small button next to the block to instantly download and apply that exact segment to the database.
It's very clean.
But let's pause here because this seems contradictory to me. If the AI is smart enough to generate perfectly valid, level 3 validated BJSON code, and it's smart enough to identify that a boss has too much health, why purposefully cripple it?
You're wondering why make it read-only?
Yeah, why not just give the AI write access and let it dynamically fix and balance the game automatically?
It comes back to the philosophy of control we discussed with the database architecture. The human developer is maintaining absolute, unquestioned authority over the cube.
So the AI might be a genius, but it lacks the macro vision.
Exactly. We call it preventing structural drift. If the AI is given the power to edit files directly, it operates on immediate optimization.
Okay, give me an example.
It might see a bug where a gap is slightly too wide for the player to jump, and to fix it, it might alter the database to give the player the hookshot item early. It fixed the immediate jump, but it just accidentally overwrote a critical connection in the macro dependency graph we talked about earlier. It broke the Zelda logic of the entire game.
Wow, okay. So by keeping the AI strictly read-only, the human remains the final arbiter of the game's logic. It ensures the AI doesn't accidentally dismantle the carefully carved checkerboard realm in its eagerness to be helpful.
It's an advisor, not a co-director. The human always holds the sword.
All right, we have the brutalist art, the incredibly strict Biji-san database, the mathematically carved map, and the read-only AI advisor keeping everything in check. Let's actually fire up the engine.
Yes, let's look at the gameplay.
Let's look at how the game plays in real time, bringing that hashtag DE26 studies thread to life.
To understand the feel of Sword Slasher, we have to examine the physics and audio integration, specifically during combat.
The combat math itself is brutally simple. It's not tracking dozens of hidden variables. It fits the Stark aesthetic perfectly.
Yeah, the code in lib_bjson_gaming_combat.tense shows the foundational formula. Damage equals max of 1, comma, attack minus defense times 0.6.
Let's break that down for the listener. The max 1 part ensures that no matter how high an enemy's defense is, an attack will always do at least 1 point of damage.
It prevents situations where a player is trapped hitting an invincible enemy for 0 damage.
And the defense times 0.6 means that armor only mitigates 60% of an incoming attack.
Right, so if an enemy has 10 defense, it only blocks 6 points of damage. You can never be fully immune to damage. The world is always hostile.
There's also a 10% chance for a critical hit, which multiplies the final damage by 1.75. And there's a level advantage bonus. If you are a higher level than the enemy you are fighting, you get a flat damage boost based purely on the mathematical difference in your levels.
It is clean, understandable math.
But while the math is simple, the physical act of swinging the sword on this screen is where the engine gets incredibly fascinating.
Let's look at the create sword attack function. In a typical retro game, when you press the attack button, the game triggers a static animation. Frame 1, frame 2, frame 3, done.
Sword Slasher doesn't do that.
Not at all. It calculates a dynamic, physical swing every single time you press the button.
It determines a base duration for the swing, 0.3 seconds for a heavy spin attack, 0.15 seconds for a fast, normal slash. But then, before executing the animation, it applies a randomized speed multiplier to the physics engine.
Most of the time, the swing executes at normal speed, but there is exactly a 15% chance for the engine to roll a heavy swing.
And when this happens, the speed multiplier drops significantly. The swing physically takes longer to complete on the screen. The sword literally drags through the digital air, simulating resistance.
And this is where the audio physics integration occurs, which is, frankly, a brilliant piece of engineering. The engine captures that exact dynamically calculated swing duration from the physics engine, and it feeds it directly into the web browser's HTML audio element.
Specifically, it alters the playback rate property of the sound effect file in real time.
It's literally algorithmic synesthesia. Think about Foley artists working on a movie. They watch the film on a screen, and when a character throws a heavy punch, they smash a watermelon with a hammer in the studio to make the sound match the physical impact perfectly.
This engine is generating live Foley art in the code. Instead of just triggering a pre-recorded audio file named heavy_swing.mp3, the code is dynamically stretching the sound wave of the standard swing to match the physical drag of the sword through the air.
A slower, mathematically heavier swing automatically calculates a lower audio playback rate. The code clamps this rate safely between 0.4x and 1.5x, so it doesn't break the audio engine or sound like a glitch.
And dropping the playback rate of an audio file deepens its frequencies. It naturally emphasizes the low-end bass of the sound. It makes the digital sword sound physically heavier and more dangerous.
Simultaneously, the code adjusts the volume of the sound effect. Normal swings are scaled down to 0.65 volume. But those slow, heavy swings get a dynamic volume boost all the way up to 1.0.
So mechanically, a heavy swing is slower on the screen. It sounds significantly deeper in pitch, and it is much louder. And the visual rendering engine matches this feedback perfectly.
Yes.
The engine draws the physical sweep of the sword using a hollow ring sector on the HTML canvas. It fills that sector with a fading gradient to look like the motion blur of a blade cutting the air. But when the physics engine rolls a heavy swing, the opacity of that fill is increased, making it look thicker.
And the sharp leading edge of the swing, the actual cutting edge, changes color. It shifts from the standard #DE2626 to an even sharper, brighter #55555.
If we pull back and look at the core aesthetic, this level of dynamic microfeedback is absolutely necessary.
Why do you say that?
Well, the game is incredibly minimalist. We are talking about strict pixel grids, flat SVG vectors, and stark black, white, and red colors. There aren't millions of polygons or high-definition textures to convey a sense of physical impact.
That's a great point. To make combat feel visceral and satisfying in a visually flat game, you must rely on procedural audio modulation, dynamic rendering tricks, and hit-stop mechanics. The entire weight of the game exists purely in the math.
Speaking of math driving the gameplay experience, we have to talk about how things move through this world. The A-Star pathfinding implementation.
Ah, yes.
The documentation contains a pathfinding parity report detailing how it was recently integrated into the engine.
A-star, often written as A*, is a classic pathfinding algorithm used in computer science for decades, and its implementation in Sword Slasher is very clean and highly optimized.
Before we get deeper into A-Star, for anyone listening who isn't a computer science major, the document specifically states it uses Manhattan distance for its heuristic. What does that mean?
Think of navigating a city grid, like Manhattan. If you want to get from one intersection to another, you can't walk diagonally through a skyscraper.
Right.
You have to walk down the block, turn the corner, and walk the next block. It calculates the distance to the target by counting those strict vertical and horizontal steps. It's the perfect, highly efficient way to calculate distance in a game built on a rigid checkerboard tile system.
So the A-Star algorithm reads the is_solid property of every tile on the grid to avoid walls and obstacles. It has an early exit maximum step limit, which is a great safeguard so the game doesn't freeze in an infinite loop if an enemy is trying to find a path to a player that is completely walled off.
Exactly. It calculates a route and populates an array in the memory called active path.
But the most important detail regarding the player experience isn't how the path is calculated, it's how the engine handles manual interruption of that path.
The engine has public routing methods, like a function called Navigate Player 2. If you click a spot on the map with your mouse, the player character will start following the A-Star path automatically to get there.
But if the player is watching their character auto-walk and they suddenly touch the manual, controls the WASD keys or the arrow keys, the code instantly intercepts that physical input. It completely wipes the active path array from memory and cancels the automated sequence immediately.
It guarantees absolute responsiveness. The automation never fights the player for control. It seems like a minor detail, but in an action-adventure game, if you feel like you are fighting the pathfinding algorithm to move your character, the immersion is instantly broken.
It all circles back to the core philosophy of control. He controls the AI advisor by making it read-only, preventing structural drift. The player controls the character by being able to override the complex A-Star pathing instantly.
The human is always the one holding the sword.
It is an incredibly cohesive digital ecosystem. Every piece of code, every database validation, every audio modulation serves the thematic vision established on day one.
It really is a masterclass in how deliberate, severe constraints in software engineering can breed incredible creativity and technical focus.
We started with a very specific, striking image, a stark checkerboard landscape, pure black and white, dominated by a massive cube with a glowing #DE2626 Crimson Sword plunged into it.
Yeah.
We've seen how that initial visual constraint wasn't just about making cool album art, it was architectural. It drove the creation of the rigid, bespoke Bojsan database to enforce perfection.
Which then informed a highly structured subtractive carving method for designing the map, chipping away at procedural noise to find the golden path.
All while being assisted by a deeply integrated yet strictly constrained AI advisor that ensures visual lineage continuity and refuses to let the developer's flow state be interrupted. Ending in a combat system where the physics engine literally bends the pitch and volume of the audio in real time to make every swing feel heavy and visceral.
It all connects.
But I want to leave you with one final, slightly provocative thought to mull over. If you've been listening closely, you know the Executive System Advisor AI is currently strictly read-only.
Right, it's a tool for the developer.
It can look at the database and suggest changes, but the human have to push the button to apply them to prevent the game's logic from drifting. But what happens if you take those training wheels off?
Oh, that's a wild thought.
What happens if you take that exact same AI, which already perfectly understands the intricate rules of the Bayesian database, perfectly understands the subtractive carving guidelines, and you feed it the live game state while a player is actually playing? What happens if you make it a real-time dungeon master?
That is a terrifying and exhilarating concept for the future of game design.
Imagine playing Sword Slasher, and the AI is watching how you play. It sees you are struggling with a specific enemy type. Because it understands the database perfectly, it could dynamically generate a new biome in the next room. It could tweak the enemy stats down slightly on the fly.
Or it could procedurally generate a brand new rusty sword with a specific elemental buff tailored to your playstyle. Write the valid BJSON code for it and drop it right in front of you in real time.
The engine architecture already supports dynamic partial updates. The AI could theoretically inject that code directly into the live state without breaking the game. Right now, the human holds the sword. But if the engine is this robust and the AI is this deeply integrated, the sword in the cube might soon wield itself. Thanks for stepping into the checkerboard with us. We'll see you next time.